it's our group's turn to discuss about the questions that we came across during the past 3 weeks when we trying to finish this final project. As for the question 2.11, we have a lot of questions about the influence caused by a more efficient process. As we all know that by incorporating the smart grid technology into our design, we will surely have a more efficient electricity generation infrastructure. But we have different ideas about what influence will be brought by this improvement. On the one hand, the electricity generation infrastructure has more ways to generate electricity, so even as the processes changes a lot, it may always find a way to satisfy the demand for electricity, which means it will depend less on other processes. While on the other hand, as the electricity generation infrastructure becomes more effective, it will inevitably need more energy and flexibility to maintain its operation. So in this aspect, it must ask other sectors to provide this service, and so it will depend more on them. And we don't know if matrix A is still appropriate for the analysis of a snowstorm in question 2.14. The first limitation we came up with is that 6 to 12 hour outage will not be available anymore for external shock of heavy snowstorm since it's a longer lasting damage. So the values listed in table 2 may not be sufficient. But except for this point, we can't came up with any other ideas about this question, so we are looking forward to your advice. And we also have a mildly nagging doubts. As for question 2.17, we wonder if the expression of with a range of 10% of the deterministic value means that the data will vary from zero point 0.9 multiplied mean value to 1.1 multiplied mean value, or it should be selected between 0.95 multiplied mean value to 1.05 multiplied mean value. So that is to say, we don't know if the 10% range is a whole range or it just refers to one side. A very big problem about the question 2.19 is that, in our opinion, to solve this problem, we need to set all the coefficients in F as 1, except for the coefficient that corresponds to air fuel and petroleum grade TCL values and finance. For these three, we set them as 0.2, 0.3, and 0.35 respectively. Then we use this F to compute the corresponding matrix X, and to say if the coefficients in X satisfy the condition that they should all be less than 1. If this is satisfied, we'll jot down. If not, we need to adjust the F to obtain the X, whose coefficients are all less than 1. Then the F is the largest one that we seek. However, we don't know if this idea is correct enough or accurate enough, so maybe you guys can give me some advice about that. And when it comes to the decision variables in question 4.20, we wonder when we are about to design a system, should we decide the number of each type of power plant, or we only need to decide whether we want to build up the 4 new proposed plant designs or not. That's all the questions that we have yet. Thank you so much for your advice.